In the last section, I laid out a couple big issues with our current caching setup. In this video, we're going to talk about those issues and propose a couple of solutions to each of them. All right, so let's take a look at a diagram. So I've listed out all of our problems on the left, and I've got a couple possible solutions on the right. So the first big problem we ran into was that our caching code, not at all reusable. Without a doubt, I think you would agree. Everything we have is inside of that one request handler. So as a possible solution, and this is going to be kind of crazy, but it's going to work out really well, trust me, I think that we need to figure out some way to hook in to how Mongoose makes a query and executes it against MongoDB. That might sound crazy, but bear with me for a second. Just think about it. Our entire caching strategy is based on the idea of somehow stopping Mongoose from making a query over to Mongo. And it also is based upon the idea of somehow intercepting the value that comes back from Mongo as well, so we can store it inside of our cache. So this entire idea of caching is incredibly tightly coupled with Mongoose and when a query is executed. Now, to really understand this step right here and what I'm going to suggest, we have to understand a little bit more about how queries inside of Mongoose works. So we're going to take a quick aside very quickly, maybe not too quickly, but I'll do my best. And we're going to take a quick review of Mongoose and what queries are in Mongoose. All right, so I already pulled up the documentation for Mongoose right here. So I'm at mongoose.js.com, and I'm looking at the queries section. So inside of here, I'm going to scroll down a little bit, and I'm going to find something that talks about like customizing queries. You'll see it right down here. So this is working with an imaginary collection of person. They make a new query, and they tack on all these additional statements here. They then limit the number that come back, they sort it, they select particular fields, and then finally they execute that query. So I want to copy paste this over to my code editor really quick, and I want to point out a couple of very interesting things about what's going on with this code snippet right here, okay? So I'm going to copy this, and I'm going to put it over in my editor, and let me turn on JavaScript. And then just because I'm super crazy and I don't like the right aligned period, I'm going to move it over to the left-hand side. Much better. And we'll fix that one too. There we go. Okay. So one thing that is not super well known about Mongoose, because it's not something that you'd ever really cared to take advantage of, is the fact that whenever we reference a collection and then start saying like find and where and limit and sort, it creates what's called a query object. So I could, in theory, assign the result of all this stuff to this query variable right here. Now there's just one problem with what I've written out so far. Person.find, like all these modifiers, the where, the limit, the sort, the select, these all return new queries that have been further customized in some fashion. However, the last line of code right here, the .execute or .exec, is what takes this query and actually executes it and sends it off to MongoDB. So I want to take that line of code off for just 1 second, okay, and leave it just like this right here. So now at this point in time, this query object right here, it represents some pending query that might be issued over to Mongo at some point in the future. So it has not been issued yet, it has not been sent over, but very shortly we can execute this query and send it off to Mongo. Now, if you think about it for a second, that entire process right there of like formulating some query and getting really close to sending off to Mongo sounds like it's incredibly related to our timeline and our life cycle of our caching system. Remember, we've said so many times now, whenever we are about to make a query off to Mongo, we first want to check to see if this data has already been fetched in Redis. That's the key. So when we create this query, and we got this query right here, and then like the next line of code might be something like query.exec, like so. This part right here, like this little gap right here, check to see if this query has already been fetched in Redis. Okay, so between formulating the query and actually executing it is when we want to make that check right there. Now this might sound like kind of weird stuff, but let's just keep going for a second. And I think you're gonna kind of like what eventually happens here. Okay, so next thing I want to do is I want to tell you a little bit more about this exec function right here, because this is not a very well-known function. As a matter of fact, if you look at all the code that already exists inside of our project, you're not going to see the word exec anywhere inside of it. But I just said 2 seconds ago, this is how we actually execute a query and send it off to Mongo. So there's actually 3 different ways, kind of like technically 2, but more or less 3, to trigger a query to be sent off to Mongo. This right here is one possible way to trigger a query. The full signature of this line right here is query.exec, and then it takes a callback that gets called with an error object and the result. And then we could say like, console log the result like so. So that's one possible way to execute a query. That line of code right there is pretty much identical. I'm going to mark this as being like same as writing out query.then result and then console logging the result. So this .then right here is, it's part of a promise, but whenever we call .then, it actually behind the scenes also calls .exec and causes the query to actually be executed. So you might have seen in the past some Mongoose code where they use a promise like this right here. That is the same thing as actually directly calling exec. And then the last way that we can actually execute this query, so same as, would be to use the async await syntax. Now async await technically is making use of the underlying promise here, but I'm going to list it out for completion's sake. So it would be something like await query like so. And this right here is what we are doing inside of our code base. So the point that I'm trying to make right now, the big point that I'm trying to make, is that everywhere inside of our code base, you and I are executing queries by writing this line of code, right? Writing that line of code is more or less the same as running this line of code. This exec function right here is operating on a query that has already been formulated. Like we've already customized this query to a tremendous degree. And before exec is called, we have this like query object thing that we could read some details in about. So again, this is going to be like kind of hard to wrap your head around right now. This is like the first taste I'm going to give you, and we're going to like really dig into this very deep. So this is just the first taste I'm going to give you, but here is the suggestion I'm going to make for getting some really reusable code. Because remember, that's what we're talking about right now. Like how do we write some reusable caching code? So I'm going to suggest that we do something really crazy. I think that you and I should figure out some way of overriding the built-in exec function. I think you and I should figure out some way to overwrite this function right here for all queries that are created. And inside that function, we should write our logic to check to see if this query has already been executed. And if it has, return the result right away. Otherwise, issue the query as normal and then save that value in Redis. Okay, so let's put in a little bit of pseudocode here to like kind of imagine how this might work, and we'll bring everything full circle. So first off, we need to check to see if this query has already been executed. So we might write something like, client.get query key, and then we'll do that same check as before. If, let's assign this to like, result or something. So if result, return result. And then otherwise, run the original query function. So remember, the idea here is that we're going to overwrite, or excuse me, not the original query function, but the original exec function. So the original exec function is what actually kicks off the query to Mongo. So I'm suggesting that we overwrite that function here. So whenever we call this new version of exec that you and I are going to make, we're going to execute this logic. If this fails, we'll then run the original exec function that's going to actually, go make the request over to Mongo. We'll then take the result of that. We'll store it inside of Redis. So we'll do something like, redis.set or client.set query key, and we'll store our result in there. And then we'll finally return the result as the exec function normally would. So what I'm suggesting here is we hijack how Mongoose works out of the box. We overwrite the exec function to kind of like insert in or like nudge in our forced caching code. And then whenever we call or whenever we make a query, by default, we can have it just automatically be cached for us. And you and I will never have to write any extra code inside of these request handlers to worry about setting up all this custom caching logic. Okay? So again, I know this might be tough to wrap your head around right now, but as soon as we start writing the code, I think you're going to get a really good idea of what I'm going for with all this stuff. Okay? I think you're going to really think this is some cool stuff, because it is, trust me. Now, before we move on, we saw these two other issues I want to address very quickly. So we just got kind of like a taste of how we're going to make this caching code super, super reusable. Now, the next thing I want to mention here is the fact that right now our cache values never expire. So Redis internally is designed to behave as a caching system. Like, they know, the people who make Redis, they know it's used for caching. So they have a couple of built-in tools to aid in common operations that are involved with caching. One common thing that's included in Redis is the ability to automatically time out values that have been set. So in other words, after we cache a value, we can tell Redis to automatically expire that value after like 5 or 10 seconds, or a day, or 5 days, or whatever we want. And so that's a very basic way that we can ensure that we do not forever cache every value inside of our application. We can say that once a value has been cached, we can keep it around for like, 15 minutes, and then eventually say, okay, that's enough, like let's dump it and refetch that value just to make sure it's the most up-to-date one. Now that timeout thing is really pretty straightforward, so I'm going to give you a very quick example of how it's done. So I'm over at my terminal again. I've got my node REPL. I created my Redis instance. Here's the URL, the client. I have deleted all the entries inside of Redis already, and I went ahead and set a new value. So you see right here, color is red. I then called client.get, and I tried to retrieve the value of color. And then I console logged the value. And I got back, as I would expect, red, without a doubt. So if I now tried to get out color one more time, I get back red again. Definitely what I expect. So now I'm going to try to update the value of color right here, but this time I'm going to add in an automatic expiration, okay? So I'm going to write in client.set, we're going to do color, we're going to do red, but now I'm going to add in 2 additional arguments. As a third argument, I'm going to add in the string EX with capital E, capital X, right, like so. EX, as you might imagine, stands for expire. So automatically expire this thing after some period of time. And then as a fourth argument, I'm going to pass in the number of seconds that I want this thing to expire after. So I'm going to say expire after 5 seconds. So as soon as I run this code and set this value, I can retrieve this value for the next 5 seconds, but after that, poof, it's just going to be gone. So let's try this out. So I'm going to run this line, and then I'm going to call get a couple times in a row. And we're going to see how long it takes for this value to expire. So there's the set. I'll now get, so there's red, 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 and null. So now you see for 5 seconds, I was able to still retrieve that value. And then after 5 seconds, it went to null because the value expired. So that's a very easy way that we can implement some very basic cache expiration, inside of our Redis system. Now that's definitely like a good place to start, but it does not really solve the issue that we saw just a moment ago when we were creating a new blog. Remember, when we created a blog, it did not appear in this list right here. And if I'm a user, if I make a blog, I expect it to instantly appear on the screen. Like, I want to see it right away. Our users don't want to have to wait for some like cache expiration, right? If you set a cache expiration of 60 minutes, then who knows, they might have to wait 55 minutes to eventually see that blog post appear on the screen. And they're going to think your website is just broken, period. So even though this expiration, this automatic expiration thing is useful, we should probably also think about some other way to reset a lot of values in bulk inside of our Redis cache whenever some user does some specific thing, like let's say create a new blog post. So we're going to come back to that topic, that like second part right there, and we're going to think about some way to much more programmatically say like, hey, this entire block of cached values, someone created a new blog post, so all these values right here, they're just done. Just throw them away, toss them out the door. Okay, so that's cache values never expire. Now, I know this is a long video, but hey, let's just charge through because this is some pretty key stuff right here. Cache key stuff, that is. That's an awful joke. Anyways, cache keys, won't work when we introduce other collections or query options. So as we saw just a moment ago, inside of our request handler of API/blogs right here, we are using a cache key. Where is it? Here it is down at the bottom. We're using a cache key of the user's ID. So as soon as we start to customize our query or the collection that it operates over in any way, shape, or form, this cache key right here is going to break down. So let me give you a good example of that. Let's say that we start to, so here's where we do that initial set right here with the cache key. So if we decide to instead cache also tweets on the user's ID as well, well, boom, we just broke everything. Another way we could very easily break all this is if we further customize the query beyond what has been added to it right now. So if I go down to where we are issuing the query, so here's the query right here. So right now the only variable in here is that ID. But what would happen if I also said like, find all the blog posts that has this user and have a title of like first blog? Well, then when I tried to issue this query right here, I would still, assuming that my cache is populated or not populated, I have further customized this query and it's now different compared to how it was before. So my result set that's stored on this cache key would need to be updated, but I don't really have any good way of customizing that in any way, shape, or form. Only using the user ID as we are right now definitely is not going to work out in the long term. We definitely need some way to not only customize the cache key based on these query options that are passed in, but we also need to customize it based on the collection that we are trying to make the query over. So for example, if I had these exact same query options right here, or this exact same kind of like filtering criteria, but I was running it over tweets or something like that instead, well, then I clearly could not only use this option, these filtering criteria, as my cache key. I would have to also somehow include some information about what collection this query is being issued over. So as a solution, and this is going to be a pretty straightforward one. Oh, I only put on here, figure out a more robust way. Well, that's not very clear. Well, I got a good solution. So let me show you something. I think this is going to be pretty clear. So I'm going to go back over to the code. Here we are. So this is the query that we were looking at just a second ago that comes from the Mongoose documentation. So you can see in here, we are looking at this person collection, and it is doing a massive amount of customization to this query. So if I ran a query that was like just those two lines right there, and then I ran a query that was all of this stuff, I would expect to get two dramatically different result sets. So I would want to store both of those query results on different keys inside of Redis. So I need to figure out some way of not only encapsulating like this collection name, but all these different options that are tagged on here as well. So to do so, we can run a function query.getOptions like so. So remember, we assigned this whole query right here to the variable query. So queries have a function on them called getOptions. This returns in one single object all of the different options that we have chained onto this query. So if we called getOptions on this thing right here, it would return to us something like find, I don't know, occupation host, and where probably like an array name.last is ghost, and so on. Basically, one object that represents all the different customizations that have been made to this query. As soon as we actually run this line of code, you'll get a much better idea of what I'm saying here. But basically, if we call query.options, we get one very unique string back that represents only this query alone. So I think that what we could do, and this might sound kind of crazy again, but if we turned this entire query option object into a string, so if we stringify, like JSON stringify this thing right here, we could use this big customized option object right here as the query key. Because this query right here, this like query string right here, this is both unique compared to any other query we might make, right? If we like change, if we subtract that out, that would then remove like maybe this block right here. So definitely as soon as we change the query, the key would change as well. So it's definitely unique. But if we always have the same options, like we always have where name.last equals ghost, then it would also be consistent. So if we take these options, turn them into a string, and use that as our key, that satisfies the requirements of being both unique and consistent across queries. Whew. Okay, I know this has been a super long video. I can't apologize enough, but I really just wanted to jam everything into one video here. So I know that some of the stuff I'm talking about sounds like crazy talk. I think the timeout stuff was pretty reasonable, but definitely this hooking in stuff and the cached key stuff sounds pretty crazy. Again, this is an advanced course, so my goal was to give you as challenging but doable as I possibly could. So we are gonna, I guarantee you're gonna learn all this stuff, okay? I know it sounds crazy right now, but I guarantee you're gonna get a really good idea of what's going on. So let's continue in the next video. We're gonna start to do a little bit deeper dive into Mongoose and figuring out how to satisfy each of these requirements right here. So it's gonna be a lot of fun. Let's continue in the next video and we'll get started.